I'm going to run a test of hypothesis here, show you how to use the PropZTest for qualitative data. All right, so our question reads, suppose that a random sample of 100 observations from a binomial population gives a value of p hat equals 0.63, and you wish to test to see if the parameter equals 0.7. So perform the test of hypothesis. So we have qualitative data here since we're dealing with p hat. So our parameter equals p. We can figure out what the null and alternative hypotheses are from reading the question. So our null, HO, this is our null hypothesis. It's always the parameter, which in this case is p, equals a value. The value that we're looking at is 0.7. And our alternative, HA or H1, however you prefer, I don't care. So our three options for the alternative hypothesis are less than, greater than, or doesn't equal the value 0.7. Well, there's no mention in the question anywhere about strictly less than or strictly greater than. It only says equals. So if we're looking for equals, that means we're looking for doesn't equal as the alternative. So that is what we have there. So that's our null and alternative hypothesis. Now, we want to check the conditions to determine if we can use a large sample test of hypothesis using a proportion. The first thing we need to know is certainly whether or not it's a random sample. It's listed in the problem that it's random, so we're good with that. So we need to check that n times p hat is at least 15 and n times q hat is at least 15. These are the criteria that we're using. Others can certainly be used. I've seen 5, I've seen 10, I've seen NPQ greater than or equal to 10, and so forth. But these are the ones that we're going to be using. So here p hat is 63, so n times p hat equals 100 times 0.63, which is 63, and that's certainly at least 15, so that's okay. And then n times q hat equals 100. 1 minus 0.63 is what q hat is. So that's going to be 0.37. So this is 37. That is also at least 15. So our checks are good. So we can use the large sample. So we're going to use the calculator to determine whether or not we should reject or fail to reject the null hypothesis. So let's turn it on. All right, so we're going to use the PropZTest. You see that there in the top of the screen there, top left. So to get there, we hit the Stat button, and we go over to Tests, which is where all of our tests of hypothesis and confidence intervals are. And you see PropZTest right there, number 5. Let's arrow down to that. You can hit the number 5 as well. All right, P sub 0 is the value we're trying to test. So this value here, 0.7, is P sub 0. So we're going to put in 0.7 for that. So X is the number successful. Let me write down the formula for P hat. So note P hat is equal to X over N. Therefore, X equals N times P hat. Well, we've already calculated that. That's 63. And if you're in a situation where Say you were given a rounded p-hat, maybe there was 101 samples instead of 100 samples, then you could just multiply these into x there. So 100 times 0.63 gives us our 63. Again, if it was 101, that would come out to a decimal. You're going to need to round that to the nearest whole number in order for this to work, because you can't have a part of a person. N is 100. And now this is the option, this fourth thing, is picking what our alternative is. Well, it's either going to be doesn't equal, or less than, or greater than. We've already chosen doesn't equal, so make sure that's highlighted. If you needed to change it, you cursor over it, hit enter, and it changes. Again, that's not the one we want. We want the original one, but that's how you change it if need be. We're going to hit calculate. And this gives us quite a bit of information here. This tells us, again, the test we're using, one PropZTest. The alternative hypothesis, we don't need the null because we know what the null is. It's always the equal sign. So the proportion doesn't equal 0.7 is what we're testing. And then it gives us the z. That z value is a test statistic. So let's scroll down a little bit on this. So we have z. I'm going to put a little subscript test and illustrate that it's a z-test, and that equals negative 1.5, we'll call it 3, we'll round it. P-hat is 0.63. This other p is the p-value, and that is 0.1266, 0.127, whatever. So our rule for the p-value is if the p-value is greater than or equal to alpha, less than or equal to alpha. Let's do it that way. It's less than or equal to alpha. We reject. Okay, which means if the p-value is strictly greater than alpha, then we fail to reject. Again, we're not proving the null, we're just failing to reject that it is incorrect. All right, so we haven't been given a level of alpha. We can scroll up, we haven't been given what it is. A default alpha that we typically use is 0.05. So if you're given, so that would be 95%, but we'll just assume alpha is 0.05. This is less than our p-value, which is what? 0.1266. Therefore, since the p-value is larger, we fail to reject. And we have it concluded. So again, there's a formula to calculate this z-test statistic. The calculator does it for you very well as well. All right, and that is how to use the one prop z-test.